So similar to some of the other linear equation problems that we've been working through, okay, we're going to look at a scatter plot and use that to help us determine which one of these four possible equations is going to best fit our y equals mx plus b formula. Okay, so the first thing is kind of recognizing that there's a general pattern here. Okay, so when we look at all of the possible scatter points, okay, all of the data that's been collected, we know that as we're going further right, we're going upwards as well. Okay, so we do have a direct relationship between these two values. Now it's not quite one-to-one. Okay, it's not going to kind of fit out all the way. Okay, because one of the things that you have to do is when you're working through a scatter plot is we need to be looking for the line of best fit. Okay, if I'm going down here, okay, most of the data is going to be, above the line. Okay, same thing if I go too far steep. If I go up here, I'm not seeing much of the data. Okay, now we do a quick count. We're talking about 2, 4, 6, 8, 10, 12, 14, 16, about 20 data points. Okay, so ideally you're going to try and have a line that kind of fits through a fair number of them. Okay, so even though we know we've got about 20 data points, if I draw a line about there, okay, we're starting to see kind of a fairly even balance. There are a few points where we're actually crossing the points. Okay, we have 1, 2, 3, 4, 5 directly above it. We have 1, 2, 3, 4, 5, 6, 7 kind of directly below it, but a few of those are really close to actually just kind of touching with it. Okay, so we know that there has to be some sort of direct relations, and they kind of already identified that. We see slope on pretty much all of these, although we can say that it's not a direct one-to-one relationship. Okay, so instead of digging through a lot of the deeper calculations, we are doing a little bit of a process of elimination to find our problems. Okay, now if we needed to, we could kind of take a couple of the data points, find the slope, m equals rise over run, the y2 minus y1 over x2 minus x1 to kind of pinpoint this. And we do have a couple of data points. We could probably use that data point, maybe that data point, to go ahead and calculate our overall values. Okay, and we may still yet do that. But one thing that we can do as part of the process of elimination is we can determine where is our y-intercept going to be. Well, this was an option of 0. Okay, we've already eliminated that one. We have an option of 1, and we have an option of 4. Well, we look at this, and if we try and have 4 as our intercept point, there's no real way that we can connect all those data points and still have it be fairly reliable. Certainly not at a 2/3 slope, or sorry, a 3/2 slope. Okay, so we can eliminate that one as well. Okay, now what that leaves us with is y equals 2/3 times x plus 1, or y equals 3/2 times x plus 1, basically a reciprocal of the slopes. Well, if we know our rise is going faster than our run, we need to have a value higher than the denominator for our slope. So we can conclude that that one's going to be about y equals 3/2x plus 1. Now if we wanted to verify that, this point we know is 4, 7. We know this point is 1, 3. Okay. So 7 minus 3 over 4 minus 1. We end up with 4/3, which is kind of close, 1 1/3 versus 1 1/2. It's going to be close enough that this is going to be an acceptable answer without even having to break out the calculator. So hope the idea of the process of elimination for solving some of your linear equation problems can help you out. But it never hurts to go back to the data and kind of check, like, are you still on the right track? Because visualization is a great way of summarizing a problem and a set of data, but using the data is going to be a stronger answer. So quick answer, product of elimination is perfectly fine. Your line of best fit obviously works. You have time to work your way through it. Do the quick calculation to figure out if your slope's in the right area. Okay. Now, if you really wanted the best fit, you could of course take all the data, put it into Excel or another spreadsheet, and a lot of software and even graphing calculators like this one will have the ability to determine that line of best fit and basically give you that more accurate equation than that. But for this project, that's more than enough. So hope this helps. Hope this helps you think about how you solve your problems and can allocate your time. But until next time, best of luck.